This video is part of a series of instruction videos on the BioGrace greenhouse gas calculation tool. This is instruction 2.1, Methodology of Greenhouse Gas Calculations, which will explain on the background and basics of the greenhouse gas calculations as performed with BioGrace. In order to fully take profit from this video instruction and the ones that follow after this one, it is highly recommended that you understand the wording and requirements on greenhouse gas calculation issues in the RED, the Renewable Energy Directive, which is the Directive 2009/28 EC, with the full name listed here. BioGrace has been built to comply with the greenhouse gas methodology as defined in the RED. Whenever I refer to the RED in this presentation, I could have said RED and FQD, because the RED and the European Fuel Quality Directive contain the same methodology and other legislative elements for biofuel greenhouse gas calculations. We advise that you are familiar with the requirements from the RED and understand the meaning of the terms default value, typical value and actual value, disaggregated default value, land use change, and fossil fuel comparator, before you continue with the current and with the next video instructions. You can become familiar by carefully reading Articles 17.2, 19 and Annex 5 of the RED. Other relevant legislative and informative documents are listed on this sheet, which I will not explain in detail. These documents allow you to learn more about the terms just mentioned, and on how greenhouse gas calculations for land use change are covered under the RED. For making actual greenhouse gas calculations, you need four things: a methodology, actual data from the biofuel production process, numbers or coefficients to convert this data into greenhouse gas emissions, and data or numbers for the reference process. The methodology in the reference process will be dealt with in this video instruction. The other two topics come back in later instructions. It is important to realize that making actual greenhouse gas calculations is a way of performing a life cycle analysis, or LCA. LCA studies can be complicated and time-consuming, as often many aspects have to be taken into account. When defining the methodology for the RED, it was realized that it would not be feasible to require an extensive LCA analysis from all stakeholders in the biofuel production chain. As a result, some pragmatic choices and simplifications were made, as for instance the inclusion of default values and disaggregated default values in Annex 5. Another example of a pragmatic choice is that for greenhouse gas calculations under the RED, it is not required to make an LCA study of the fossil fuel pathways, which is the reference scenario for the LCA analysis. Instead, a predefined number, called fossil fuel comparator, can be used, to which I will come back in a moment. The methodology in the RED contains this formula to calculate the greenhouse gas emissions from biofuels. In this formula, the capital E represents the total emission of the biofuel for which the calculation is being made. EEC, EP and ETD are the three contributions to the total emission for which disaggregated default values have been defined in the RED. EEC is the emission from the extraction or cultivation of the raw materials. EP is the emission from processing, and ETD the emission from transport and distribution. EEE is the emission saving from excess electricity from cogeneration. This saving is combined with EP. EL is the emission from land use change, and ESCA the emission saving from soil carbon accumulation via improved agricultural management. Both can be calculated following the decision on carbon stocks, which is mentioned on one of the previous slides. EU is the emission from the fuel in use, so due to combustion, which is zero for biofuels following Article 13 of Annex 5.c of the RED. This is because the carbon in the biofuel is short-cyclic. It is absorbed by the crops and released upon combustion of the fuel made from the crop, directly or after the biomass has first been used and was then turned into a waste or residue. And finally, ECCS and ECCR are the emission savings due to carbon capture and geological storage and carbon capture and replacement, respectively. They are not often applied, but we have seen examples, including greenhouse gas calculations. A biofuel production pathway will look like this. Often a crop is cultivated for which sometimes land use change has occurred, or for which improvements in the agricultural management have been made, leading to carbon accumulation. Improved agricultural management has to be calculated at the cultivation stage. The harvested crop is processed. At various stages in the pathway, crops, intermediate products and biofuels are transported. In the calculation, we take the different contributions from cultivation together, as well as the different contributions from processing and transport. In the BioGrace Excel tool, the result box looks like this. In this result box, you can identify the several contributions from EEC, EP, ETD, EL, and ESCA. Some important elements from the methodology, as given in Annex 5.c of the RED, are listed on this sheet. Many of them, like the energy-based allocation of co-products and the bonus of biofuels from degraded and heavily contaminated land, have been heavily discussed amongst LCA experts and policymakers. Being defined as they are in Annex 5.c of the RED, they provide a basis for making actual greenhouse gas calculations. Nevertheless, there are more detailed issues that have not been defined in the RED. Therefore, BioGrace has developed a set of calculation rules that are the subject of the following video instruction. The last topic of the present video instruction is that of the reference process. A fixed emission value for the reference process, which is the use of fossil fuel in transport, is given in RED Annex 5.c under point 19. The fossil fuel comparator is 83.8 grams CO2 equivalent per megajoule, and is the same for diesel and gasoline. This is the value in the RED as it was published in 2009. Most probably, this number will change when Annex 5 is updated. If so, you will find the most recent number in the BioGrace Excel tool. Here you see the 2009 number, which still applies when producing this video instruction in 2013.